Hello everyone. Today we're going to talk about the slopes of parallel and perpendicular lines. So you remember on Friday that we reviewed how to find the slope from a graph, which is just counting rise over run, and how to find slope from 2 points, which is the formula. Today we're going to look specifically at what it means when the lines are parallel, what to look for in their slopes, and then the same thing for perpendicular. So remember that for parallel lines, this is an example of what they would look like. So those lines never touch, ever, and they're on the same plane. So in this case, the XY coordinate plane. So what is special about their slopes? So if you open the inside of your booklet, on the left side, you'll see a little box. In the coordinate plane, two non-vertical lines are parallel if and only if they both have the same slope. So that's the important part. They are going to have the same slope. And then the definition did say non-vertical, so what's special about vertical? Well, two vertical lines are always going to be the same. Remember that the slope of those were undefined. So we have 3 examples to look at. So first off, we have this picture here, and it says, find the slope of each line, and then is A parallel to B? Remember that symbol means parallel. So let's start with A. So I'm just going to write the letter A down here. So we need to pick 2 perfect points that are going through the corners. So I think right here would be a good point at -4, +2. And then at 2, 4. So right here. So if you make your triangle, it'll make it easier to count. It's going 2 up and 1, 2, 3, 4, 5, 6 across. So 2/6. We could reduce that to 1/3. So the slope of line A is 1/3. Okay, now we want to do the same thing for line B. Okay, so let's pick 2 perfect points. So it looks like right here, -2, -4. And then if I just follow that up, it looks like on top of the x-axis, 5, 0. So if I do my triangle here, I have to go 1, 2, 3, 4 up, and 1, 2, 3, 4, 5, 6, 7 across. So the slope there is going to be 4/7. So while they kind of look like they might have been parallel, like they don't touch here in the picture, they have different slopes. They are not the same. So these are not parallel because these 2 things are not equal. Okay, so let's try another one. So find the slope of each line, and then is A parallel to B? So let's start with A. We need to pick 2 perfect points. Looks like here, -4, +4, and then again at -2, +3. So we can make our little triangle. It's going 1 down, so I would call that negative, and then 2 across. So that is -1/2 for our slope. Now let's look at line B. So -4, -3 looks like a good point. And -2, -4 looks like a good point. So we're going to do the same thing and then count -1 and then across 2. So this one also has the slope of -1/2. So this time they are equal. So because they are equal, yes, these are parallel. Or you can say A is parallel to B. Okay, and then the third example here is a little different. So we only got one line, but they want us to draw a line that is parallel to the line A, so the one that's already there, and passes through point P. So you'll see that they gave us a point right there. So I think the first thing that we probably need to do here is figure out what is the slope of line A. Okay, so we need 2 perfect points. I think this one is a good one. -2, +4. And then right here at 1, 2. If I do my triangle, it's going 2 down and 3 across. So the slope is -2/3. So remember, I'm trying to keep it parallel. So I need to use the same slope. The only difference is that I want it to go through this point, point P. So I'm gonna erase some of my markings here, that way I don't confuse myself. Okay, so I want a parallel line through point P. Okay, so starting at that point, we're gonna count the slope that we got. So down 2 over 3. So that would be another point. And then I'm going to work backwards a little bit. So it'd be 2, 3, 2, 3, just counting the dots. And then I can connect those dots. And there's my line. And it's going through point P just the way that they wanted me to. So the trick is just making sure that you use the same slope, and then your lines will be parallel. All right, so that is parallel. The second type of line that we wanted to look at is perpendicular. So just here's an example of perpendicular, very simple example. So these do intersect, but they intersect at a right angle. That is super, super important. So 90-degree angle. So how do we make sure it's going to make 90 degrees when we are looking at lines in the coordinate plane? So again, it does have to do with their slope. So if you open up the booklet, here the definition says, in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. So I hope you guys remember that the word product means to multiply. So if I were to multiply the 2 slopes, it's going to give me -1. Another way that you might have learned this previously in another class is that their slopes will be, or slopes are opposite reciprocals. So opposite just means positive, negative. So one will be positive, one will be negative. And reciprocal means that if it's a fraction, you're just going to flip it over. Okay, so let's take a look. Here's our first one, and we're going to do what we did with the other ones. Find the slope of each line, and then is A perpendicular, so different symbol, perpendicular to B. So starting with A, we need perfect points. So it looks like right here at -2, +3. And then again at the y-intercept, so 0, -2. So if I can make my triangle, and I'm going to count 1, 2, 3, 4, 5. So -5, 1, 2, 2. So the slope of line A is -5/2. Okay, I'm going to erase that because I don't want to get confused. So now I want to do line B. So we need 2 points. Looks like -2, 2. And then the x-intercept at 3, 0. So reading left to right, going up 2, 1, 2, 3, 4, 5, and 5 across. So the slope of this one is 2 over 5. So take a look at those slopes. They look almost the same. It's just that they are upside down. So 5 over 2, 2 over 5. And then one is negative and one is positive. So this is what I was talking about. These are opposite reciprocals. But the way that you should check is by checking their product. So if you were to multiply 5 over 2 times 2 over 5, just type that into the calculator and see what you get. So when you type it in, you do get -1. So that's the other part of the definition. The product is -1. So for this one, yes, these are perpendicular. So since we proved that they're perpendicular, I'm going to erase some of my writing from up here. But since we know that they are perpendicular, if we wanted to, we can go ahead and put that little square there because we know that's a right angle. Okay, let's look at another one. So judging by the picture, it looks like they are going to be perpendicular, but remember, you cannot just go off the picture. You have to actually prove it mathematically. So let's find the slope of line A first. -2, -2. And then let's find another one. 3, -3. So it went down 1. And 1, 2, 3, 4, 5 across 5. So the slope there is -1/5. Now let's look at the other line, so line B. Looks like its y-intercept is at -1. And it looks like it's going through this point here, 1, 5. So let's count. 1, 2, 3, 4, 5, 6 up, and then 1 across. So 6 over 1, remember, you could just write 6. So this time, we're going to look at their slopes. It doesn't look like it's following the pattern that it's supposed to, but I do want to double check. So the way I'm going to double check is let's multiply these numbers. So -1/5 times 6. And let's see what we get. So when I typed this in, what I got was -6 over 5. So that's not 1. I wanted it to be -1 and it's not. So since it doesn't equal -1, these are not perpendicular. So you can't just judge it by the picture. You have to prove it mathematically. More than likely, one of them is like 89 degrees and the other one is 91. Super close, but not exactly perpendicular. Okay, and then last one. So this time they only give us one line and they give us a point. They want us to draw a line that is perpendicular. So first, let's find the slope of the line that they gave us. So line A. Right here is a good point, -2, -5. And then right here, -1, -3. So if I count, they're going up 2 over 1. So the slope is 2 over 1, but we could just write 2. So if I want to get a perpendicular line, what I need to do is make it opposite. So since this was positive slope, I'm going to need to have slope that's negative. Since it's point P, I'm going to write P. So I need it to be negative slope. And then also see this fraction that we had to begin with? We're going to flip that over. So we're going to do 1/2. So starting from this point, point P that was given to us, let's count down 1 across 2, down 1 across 2, down 1 across 2, and then just do as many points as will fit. Then you can connect all your dots. Something like that. And there's my line. And since I made sure to use slopes that were opposite reciprocal, or you could even double check by multiplying, 2 times -1/2 gives you -1. I made sure to make these perpendicular. That means that they make a right angle, and I can draw my square here. Okay, guys, so that is perpendicular. A little bit more work than parallel, but not too bad. Just upside down, make it negative, or really you should be checking this. The product is -1. So this is going to go into your notebook. All it has to be is folded in half and cut on the dotted line. I believe this is going to be page 16. I'm not 100% sure on that, but glue this into your notebook, and you should have picked up a white paper. That is your assignment for today. It is exactly what we just did on the notes. You have to find the slope of 2 lines and then tell me whether they are parallel, perpendicular, or neither. And that's it for today. And just when I see you guys tomorrow, let me know if you have any questions. Bye.